Welcome, ladies and gentlemen. Today we're going to be talking about radiation and radioactivity. The first thing we're going to do today is define radioactivity, which is when the nucleus of an atom changes so that energy is emitted from the atom. And this can be for both fission and fusion. It's an all-encompassing term. Radiation can occur naturally. When it does, we say that it undergoes radioactive decay. This is when the nucleus gives off energy, usually in the form of heat or light. This happens when a parent nucleus, as seen in the picture below, splits into a daughter nucleus and an alpha particle, so a slightly smaller nuclei. In order to get a lot of energy from this radioactive decay, you can split or fuse a bunch of atoms at once. This is called a chain reaction, also known as an atomic reaction. Once started, it will continue indefinitely on its own, usually until it runs out of fuel. Radiation can also be man-made. There are two types of reactions that take place, and these will also undergo chain reactions, which is why we see a massive amount of energy when these happen. The first is going to be fission. Fission is when the nucleus of an atom splits apart. So you can see in our diagram here, we have a large nucleus. What will happen is we will fire a neutron at it, which causes it to split into two smaller nuclei, and it releases a massive amount of energy in the forms of heat and light. We should note that fission is what takes place in a power plant. It's also what takes place in the atomic bomb, and is the most common nuclear reaction that we're going to have. Our second reaction, however, is fusion. And fusion happens when two atoms' nuclei smush together, or they combine, to form one big new nucleus. So in our diagram, we have our two smaller nuclei fusing or combining together to form our large nucleus and our energy. Again, energy is released as both heat and light. Fusion reactions take place in the sun or in stars. They're also in the hydrogen bomb. Now, we talked about how fission reactions can take place in a power plant. So we want to take a look at how we can control those chain reactions that occur when we undergo fission so that the power plant doesn't go nuclear and release all that radiation into the environment. So if you lift up the flap on your notes, you'll see this picture that shows us a uranium-235 atom. And what's happening is that uranium-235 atom is hit with what we call a slow neutron. The slow neutron triggers a fission reaction, which releases energy in the forms of heat and light, as well as another neutron. And these neutrons that are released pass through what is known as a moderator. You can think of it like a screen that helps direct the neutrons to more uranium-235 atoms. This process will continue over and over again in a chain reaction, releasing more neutrons and more energy, and eventually we absorb our neutrons into these things called control rods, and this is how we slow down or stop our reaction. Eventually all of our neutrons are absorbed so that we can no longer split the uranium-235 atoms. The only other way this reaction would eventually stop is if eventually we split all of our uranium-235 atoms so that there is nothing left.